Good afternoon. I'm Stephen Aira Juma, a teacher at Bosco Secondary School, here to talk about SALTS, a continuation of the topic salts that I had started, and I hope we stopped at the properties of salts. Yes, in our previous class, we discussed three properties of salts, and the properties were properties of salts that categorize salts into three. One was hygroscopic salt, hygroscopic salts. We also talked about the liquescent salts, and we were to talk about today a fluorescent salt. So I had talked about hygroscopic salts, I had given examples, and also for the liquescent salts. So today, let's talk about efflorescent salts and what efflorescent salts are. Efflorescent salts. Now these are salts that when left exposed in air, that is overnight, lose their water of crystallization and turn into powder form. Such salts are said to be efflorescent. These salts do so through a process. So the process by which salt crystals lose water of crystallization. And turn into powder when left exposed in air, is known as efflorescence. Now this is the process. So we should be careful to give an answer to this, because if they talk about a fluorescent salt, then these are actually the substances, the salts themselves. But if they're talking about efflorescence, then it is the process by which water of crystallization is lost. So as learners, we should be careful to note that when we are asked about process, then we say efflorescence, and when you're asked about salt, then we talk about efflorescent salt. And if you're asked about property, again, a fluorescent property. That is all about the properties of salts that makes us categorize the salts into 3. Like I said in our previous class, there are 3 types depending on these properties, and we are saying the properties are either hygroscopic. If not hygroscopic, we talk about deliquescent. If not deliquescent, we talk about efflorescence. Now, I also promised to come discuss methods of preparing salts. Methods of preparing salts. Preparing salts. Methods of preparing salts. That is what we have to discuss today. Now, when talking about methods of preparing salts, we see the method of preparing a salt actually depends on whether the salt is soluble or not soluble. So, let's discuss solubility of salts. Solubility of salts. And we're discussing solubility of salts because you're seeing the method of preparing, the methods of preparing salts mainly depends on the solubility of the salts, solubility of the salts, solubility of salts, solubility of salts. Now, to discuss solubility, we'll make a table here of salts versus solubility, and we're saying here, so we'll have salts here, and on the other side we'll talk about details on solubility of the salts. Solubility of salts. The salts we have that we can talk about here are known to us, and we are saying that the salts, the first ones we'll deal with are nitrates. What do we know about solubility of nitrates? Now, for sure, all nitrates are soluble. All nitrates are soluble. So be it lead nitrate, be it silver nitrate, sodium nitrate, calcium nitrate, we are saying all nitrates are soluble in water. Second category of salts you're going to discuss here, solubility, are to do with chlorides. Chlorides. And again we are saying all chlorides are soluble. All chlorides are soluble. All chlorides are soluble. We also have hydrogen carbonate. Hydrogen carbonate salts. The hydrogen carbonate salts are also all soluble. All are soluble. We'll also jump to sulfates, and we're saying all sulfates are soluble. All sulfates are soluble. Now, for chlorides and sulfates, we're saying yes that all are soluble, but there are some exemptions. So to start with, All chlorides are soluble, yes, but we have two that are not soluble, except, and we're saying except two, that is lead chloride. That is one of the chlorides that is not soluble. And number two, the chloride that is not soluble we have is silver chloride. Silver chloride. There is a detail about lead, and for lead we are saying lead is soluble sometimes in warm water. Warm water. Warm water. So lead chloride dissolves whenever the water is hot or warm. Silver chloride, completely insoluble. Completely insoluble. Completely insoluble. Insoluble in water. In water. Completely insoluble in water. And again, we have talked about sulfates, and we're saying sulfates are all soluble, but we have exemption, and we're saying except three, and we have three sulfates that are not soluble. We are saying these three are, one we have is lead sulfate, insoluble. We have calcium sulfate, insoluble. And lastly we have barium sulfate, insoluble. These three are completely insoluble. So we are saying the three sulfates here are insoluble. Insoluble. Insoluble in water. Insoluble in water. Insoluble in water. Insoluble in water. The next category of salts has to do with carbonates. Remember, there's a difference. There is a difference between carbonates and hydrogen carbonates. So when you're talking about hydrogen carbonates, the formula is HCO3. And when you're talking about carbonates, we are saying it is CO3. And so we are saying all carbonates are insoluble. All carbonates are insoluble. All carbonates are insoluble. All carbonates are insoluble. Except for carbonates, except 5 of them. That is ammonium carbonate, and ammonium carbonate is soluble. Sodium carbonate, we're saying is soluble. And lastly, potassium carbonate is soluble. So for these three, we're saying soluble. But for these two, do not exist. So we're saying carbonate of aluminium, and carbonates of aluminium and iron 3, aluminium and iron 3 do not exist. Do not exist. Do not exist. Do not exist. And lastly, to summarize solubility of salts, we can also talk about here salts of potassium, sodium, and ammonia. Salts of potassium, sodium, and ammonia, all are soluble. All are soluble. All are soluble. So we are saying, if you were to discuss how to prepare or to describe how to prepare a salt, first thing you must know about the salt is the solubility of the salt. It is very important to note and know the solubility of the salt, so that as you describe the preparation of the salt, you are using the correct method. The method you're going to discuss very soon, methods of preparing salts, all depend on the solubility of salts. So as a student, as a learner there, we are saying for us to prepare salts, we must know the solubility of salts, and we are saying all nitrates are soluble. There's not even one that is not soluble. All of them are soluble. For chlorides, we are saying all chlorides are soluble, except lead chloride and silver chloride. So we are trying to say that chlorides are soluble, but these two are insoluble. Then we have noted very clearly that for lead chloride, it is soluble in warm water, but the silver chloride is completely insoluble. And again, we are saying hydrogen carbonates, and for your information, solid carbonates that we have are actually sodium hydrogen carbonate and potassium hydrogen carbonate. These ones can be found in solid form. The others, like calcium hydrogen carbonate and magnesium hydrogen carbonate, are just formed in reactions. And so we are saying all carbonates, all hydrogen carbonates are soluble, very soluble in water. So the ones we have, two of them, we're talking about, that is sodium hydrogen carbonate, potassium hydrogen carbonate, all are soluble in water. Second category, that is number 4, this was the first one, second one, third one. The fourth category is now sulfates. And we're saying all sulfates are soluble except 3. All sulfates are soluble except 3. And we're saying the sulfates that are insoluble are lead sulfate, calcium sulfate, and barium sulfate. All these 3 are insoluble in water. Then we went on, we have talked about carbonates, and we are saying all carbonates are insoluble. All carbonates are insoluble except 3, and the 3 are ammonium carbonate, sodium carbonate, and potassium carbonate, which are actually soluble in water. Then we have said there are 2 metals here that do not form carbonates, and we will learn more about this as we continue discussing salts. So we are saying carbonates of aluminium and iron 3 do not exist, and simply because of how aluminium salts behave when in solution form, which we'll discuss in our next lessons. We will discuss why the aluminium and the iron 3 carbonate do not exist. Then we are saying salts of potassium, sodium, and ammonia, meaning any salt of potassium, any salt of sodium, and any salt of ammonia are all soluble. This gives us the whole information about solubility of salts. And so we are saying out of these 6 statements here, we are able to categorize salts as either soluble or insoluble. So it is very easy for you to know the method of preparing a salt as long as you know its solubility. Now I want us to go directly to the methods of preparing salts. Methods of preparing salts, which I've said entirely depends on the solubility of the salts. Entirely depends on the solubility of the salts. entirely depends on the solubility of the salt. So we're saying methods of preparing salts. Salts. Methods of preparing salts. Methods of preparing salts. Methods of preparing salts. Under methods of preparing salts, again, I would want us to divide this into two. On one side, we will say methods of preparing soluble salts. And on the other side, what I would want us to note is actually the opposite of this. That is now methods of preparing insoluble salts. Methods of preparing insoluble salts. Insoluble salts. Methods of preparing insoluble salts. Now today we will list the methods, and I will introduce one method. Then in our next classes we'll discuss the other methods until we finish all the methods of preparing salts. So we are saying the first category of the methods, I will number them. The first one here will be A, where we're saying an acid reacting with a metal. An acid reacting with a metal. Obviously the metal is a solid, the acid is an acid solution, an aqueous solution. A method number two we'll have, which falls under category 1, we'll talk about still an acid, that is aqueous, plus a metal carbonate. A metal carbonate. A metal carbonate. A metal carbonate. And we're saying here a metal carbonate again is a solid, and we'll learn and we'll get to know why all of them are placed under category 1. Then our category 2, we'll have the first one will be an acid. You're wondering why an acid is everywhere here. We will also discuss that. An acid plus a metal oxide. Metal oxide. And again, the metal oxide is a solid. We would also talk about B here, an acid aqueous plus a metal hydroxide. And we're saying still a solid. The hydroxide is a solid. Then we'll jump to our category number 3. And in the category number 3, again, we have the first one. Still an acid is there, aqueous. But this aqueous reacts with a metal hydroxide. A metal hydroxide. But this time round, the metal hydroxide is not a solid, but an aqueous solution. An aqueous solution. And The second category again, still an acid reacting, and we're saying an acid in our case, plus metal carbonate, which is actually a solution in this case, a metal carbonate that is a solution. It can also be still C. In the place of a carbonate, you can also have a C, and that is an acid plus a metal hydrogen carbonate. I have categorized all of them into 1, 2, 3. So the ones that are in category number 1, they have some similarity. There's a similarity there, there's also similarity here that we'll discuss as we discuss these methods one by one. Then number 4, which is a method that can be used on both sides, that is number 4, we are saying direct synthesis. Direct synthesis of salts. Direct synthesis, which simply means direct combination, directly combining elements to form salts. Elements to form salts. To form salts. It is also a method here. It will be the first method here. It can be used here. So number 1 method here, as a method of preparing insoluble salts, we have what we call precipitation. Precipitation of salts. Precipitation of salts. Sometimes referred to as double decomposition of salts. Decomposition of salts. Double decomposition of salts. And again we are saying there is a number 2 method which I'm saying used on both sides. Direct synthesis can also be used. Direct synthesis can also be used to prepare, here to prepare some insoluble salts. Some insoluble salts. That is a table that gives a summary of the methods of preparing salts. I will start today, I'll only discuss one, and that is acid versus a metal. Using an acid and a metal to prepare salt. What are the conditions? What are we supposed to do? What is it we are supposed to do at the end of this? After discussing this, this will give us a hint on what to say about acid versus a metal carbonate in preparing salt. There we go. So we are saying our first method, the first method we're discussing today, which will mark the end of our discussion today, is preparing salts using. So we are saying our first method, and we are saying preparing salts using an acid and a metal, an acid and a metal, using an acid and a metal. Preparing a salt using an acid and a metal. An acid and a metal. Now, in preparing a salt using an acid and a metal, the salts that can be prepared under this category would first depend on what the acid, how there are conditions on the acid and a condition on the metal. Number one, about the acid. Dilute acids are normally used. Dilute acids are normally used. So the acids you're using here must be dilute. Normally used. And you're wondering why in the whole table and in the whole methods we have been talking about an acid versus a metal, an acid versus a metal carbonate, an acid versus a metal oxide. Salts are derived from acids. Salts are derived from acids, and you learned this in Form 1 chemistry, that is under acids, bases and indicators. And just to give you a summary, we'll talk of an acid somewhere there, then you talk about the salt derived from it. Salt derived. From acid. So if the acid is, let's just make the table so that we are together. I want us to flow together here. And so we are saying, if the acid is hydrochloric acid, hydrochloric acid, the salt that will be formed is actually a chloride. And if the acid is sulfuric sulfuric 6 acid, then the salt we will derive is actually a sulfate. And if the acid is nitric 5 acid, the salt we will get from here is actually a nitrate. And this can continue here. We can say phosphoric 5 acid, phosphoric 5 acid. The salt we can obtain is actually a phosphate. We still have others, organic acids, where we can say alkanoic acids. And we are saying for alkanoic acids, you will get salts that are known as alkanoids or alkanoids, depending on which alkanoic acid you are discussing. So this is a summary on which type of salt or which salt you can get from an acid. This is just a by the way. You need to know the salts obtained, because I can't give you an acid and expect you to tell me which salt is going to be formed. So we are saying The salts formed are formed according to the way the table says. This gives a summary of the salts derived from the acids. It is very important to note the salt and the acid that it is formed from. Now, so I've said the acids must be dilute, and we always use dilute acids to react with the metals. Now, the other thing which has to be a condition here when using these acids, when using the acids and a metal, is on the metal. That on the side of the metal, a metal used to prepare a salt using this method, the metal must meet the following conditions. It must be a moderately reactive metal. Must be a moderately reactive metal. But also higher in the reactivity series. Than hydrogen. You may be wondering why. Now, yesterday when we were defining a salt, the first definition we used, we said a salt is an ionic compound formed when the hydrogen of an acid is displaced by a metal or an ammonium ion. That means the hydrogen has to be displaced. And we always say that in a displacement reaction, we say this is a reaction, in which a more reactive element takes the position of a least reactive element in a compound or solution So it means if hydrogen has to be displaced, then the only element that can displace hydrogen is that element or that metal that is more reactive than hydrogen. And that is why we are saying the metal here, yes, it must be moderately reactive metal, but at the same time must also be higher in the reactivity series than hydrogen, meaning it has to be more reactive than hydrogen. Now, why are we saying it has to be a moderately reactive metal? Now, number one, metals like potassium, sodium, and calcium cannot be used in this method. And why is it so? This is because this is because they react very explosively with dilute acids. And again, we are saying metals such as copper, silver, cannot also be used in this method. And we're saying this is because they cannot displace hydrogen from the acid. Now, because of time, I will put down a question type here that will guide us in our next lesson on how to prepare salt by the reaction between an acid and a metal. And so I'll say our first question, which will be a leading question in discussion, is describe how you would prepare dry crystals of zinc 2 chloride starting with zinc metal powder and dilute hydrochloric acid. This is what we'll start with in our next class, and we will discuss this and see how this method is used to prepare salt. Otherwise, I wish to rest my case there because of time. We'll meet in our next lesson. Be safe, keep safe, sanitize your hands. Corona is still around. It is still messing us around. So as you stay safe, also continue learning chemistry. Thank you very much. Blessed day.